Osmolality is a measure of how much one substance has dissolved in another substance. The greater the concentration of the substance dissolved, the higher the osmolality. For example, very salty water has higher osmolality than water with just a little bit of salt. A hyperosmolar extracellular environment is present when a cell's extracellular fluid does not have enough water retained, having an increased sodium concentration in the extracellular fluid. Because of this, the cells shrink. This is dehydration. This could happen on a very hot day. The main two conditions of this are that osmolality is high and blood pressure is low. The low blood pressure and high osmolality are deviations from homeostasis. The body has its own mechanism to counteract these changes, which influences water volume. The hypothalamus is in charge of osmoregulation. The hypothalamus detects that the body cells do not have enough water. The hypothalamus then stimulates the posterior pituitary gland with hormones so that it secretes ADH into the bloodstream and to the kidneys. After ADH is secreted, it targets the kidneys, causing them to reabsorb water, sending the water back into the bloodstream. There is now a net effect of urine production decreasing. This will ultimately decrease the osmolality in the blood, bringing the person back to homeostasis because the water volume has increased. ADH causes blood vessels to constrict. When the blood vessels constrict, their diameters narrow. Even though the overall blood volume may be lower, the area the blood has to fill is less. Therefore, the blood pressure is increased, which will bring the person back to homeostasis. Because urine production is decreased, there is an increase of water reabsorption. This adds water to the blood, increasing the volume of circulating blood. This assists in elevating blood pressure. As water is added to the blood, it dilutes the solutes in the blood and ultimately decreases osmolality. Lowering osmolality and increasing the blood pressure will help the body return to homeostasis, or the set point for water volume in the body's cells and bloodstream. Whereas the person had thirst and did not urinate as much, they will be more hydrated and will urinate more frequently now. On the other hand, if osmolality is too low, if the body has too much water, the posterior pituitary stops releasing ADH. The atrial natriuretic hormone, or ANP, is the antagonist hormone to ADH, which blocks its secretion. Stretching of the right atrium of the heart due to a high blood pressure causes secretion of ANP hormone into the blood. This causes the kidneys to absorb water from the bloodstream and for blood vessels to relax. Blood pressure decreases and urine production increases. There is sodium and water loss because of the increased production of urine. This reduces the volume of circulating blood, also decreasing the volume of water. This raises osmolality, back to homeostasis. ANP essentially has the converse effects of ADH. Both ADH and ANP take part in negative feedback loops. They oppose each other based on how much water the body has. Because of this, both hormones help the body maintain homeostasis by keeping the volume of body water at a set point.
Created using Powtoon.